Okay, this is section 5.1, solving inequalities by addition and subtraction. It's on page 289, Algebra 1. Okay, you understand that we've done equations in the past. An equation looks something like this. X minus 12 is greater than or equal to 8. Okay, I'm sorry, we've done is equal to, correct? And what is the first thing we do? We change it to addition, correct? And then we subtract a negative 12 from both sides, and we get x equals plus a positive 20. Now I went through that pretty fast because we've done those quite a bit, correct? All right, well, we're going to go a little bit further today, and we're going to talk about the concept of inequalities, okay? Now, there are several inequalities. There is this one, which is less than. Okay. There is this one, which is greater than. This one, which is less than or equal to. And then there's this one, which is greater than or equal to. Those are the four. All right. Now, these two are different than these two. When we graph this, we're going to use an open circle. And we're going to have to graph today. We're going to use a closed circle. Now you're going to figure out what I'm talking about in just a little bit, but I wanted to get those out in the open. Okay? All right. So we're going to solve inequalities. And folks, if you solve inequalities, addition, subtraction, okay, it does not matter. They work just like an equation. So I'm going to start here with let me give you some directions. I'm going to say solve each inequality. So solve each inequality. Write your answer in set builder notation, and I'll explain all this in a minute, and interval notation, then graph. So there's 3 points there. 3 points. And you have to do all three. Okay? So let's take a look here at this one. 22 is greater than x minus 8. Okay, this is an inequality. It has the greater than sign. And we want to solve for the variable x. All right? So first of all, I do it just like I do an equation. I change all subtraction to addition. So I go x plus a negative 8. Okay? And then I ask myself what operation is being applied to the variable. It is addition. What operation do I use to undo it? It's subtraction, or it's addition. So I subtract a negative 8 from both sides. And I get plus a positive 30, and this is greater than, and this is x, okay? Now, there is one bad thing about inequalities. I ask that you put the x on the other side. X should always be on the left side, so we read it left to right, okay? Now, you'll look here, x is less than 30. If I read it right to left, x is less than 30. Is that correct? It's opening up to the 30, which means the 30 is greater than x. Charlie, do you understand that? Okay? So, when I turn it around, I use what I call set builder notation. It looks like this. You write x, you write a squiggly, and then you write x and then a bar. Okay? Now this means 4x. 4x, okay? And then I write x first, and it looks like I switched the sign, but I do not. I write, because x is less than 30, I write it like this. This is called set builder notation. Allie, do you have any questions about that? All of your answers are to be written in this form, okay? With x on the left side. So we read it left to right. Do we understand that? Okay. Now, the next thing I'm going to do is I'm going to graph it, because it's easier to write interval notation if you graph it first. Okay, so somewhere on my graph I'm going to put 30. I like to put 30 right in the middle. And to the right I'm going to put 31, and to the left I'm going to put 29. I want x is less than 30. I put an open circle on 30 because it does not include 30. And that goes back to this open circle up here. I put an open circle on 30 because my answer does not include 30. And then I shade. I want all the numbers that are less than 30, so I shade to the left. Now I'm going to give you a little hint here, and notice I shade the arrow. I don't shade above it, I shade right on the line, and I shade the arrow. That's exactly how I want you to do it. Notice that this arrow right here that I'm pointing at and this arrow go the same way. If you have x on the left side, that will always be the case. They will go the same direction. Okay, so now I've solved the inequality. I've written in set builder notation. I've graphed. The last thing I need to do is do interval notation. Now, it's always easy to do interval notation, and all the upper level math classes use interval notation. That's why I'm teaching it to you now, so that you'll have it down before you get up there. And it looks like this. We use parentheses and brackets. We use parentheses and brackets. Okay? Tater. If it touches it, it's a bracket. Okay? If it touches it, it's a bracket. All right? So what we want to do is, this goes to negative infinity. We read it left to right. This goes to negative infinity. I cannot touch a negative infinity. So Jackson, I use a parentheses, which means I do not touch a negative infinity. I write negative infinity. That's how you write negative infinity. It looks like an 8 laid down. Negative infinity. So we start at a negative infinity and we go to 30. Do I touch 30? No, I do not touch 30 because it has an open circle. Therefore, I have a parentheses. This is called interval notation. Now I've completed all three methods of finding an answer. Chuck, do you understand that? Do you have any questions? You do? No, not yet. All right. So let's take a look at a second type of problem. It's a two-stepper. Okay, we have 3x plus 6 is less than or equal to 4x. Okay? All right? All right, this is a two-stepper. It has variables on both sides. What would you like to do? You do what?
I would get 4x on the other side.
You would subtract 4x over here? Okay, so then I'm going to go against that just to be mean. No, I'm going to subtract 3x from both sides. Okay, and I'm going to show you why later on, but not now. I'm going to subtract 3x from both sides. Now the reason that Ashley wants to do that is she knows her answer has to be on the left side. Correct? Her x has to be on the left side. Is that true, Ashley? Mm-hmm. Good job. Okay, but I'm going to hold off on that. Okay, so please do it like this. Ashley, there's a reason for this. I'm not just being mean. Okay. All right, once again, the x is on the right side, so in set builder notation, we do 4x. This means 4x. And when I say 4, I mean F-O-R, 4x. Okay? X, and then I'm switching around. X, and it looks like I switched the sign, doesn't it? But it goes to the x, doesn't it? Whoops. this should be 6, and x is greater than or equal to 6. Do you understand that, Jackson, how I turn that around? Jackson? Okay, this is called set builder notation. Now I graph it. I take the number that my answer is, 6, I put it in the middle, and I go 7 and 5. Do I have a closed circle or an open circle, Tirsa, on 6? A closed circle. And I shade to the? I shade to the? Right. I want all the numbers that are greater than or equal to 6. And this arrow and this arrow point the same way. Okay? Now, I'm reading it left to right. Do I go to negative infinity? If I'm reading it left to right, where do I start on this graph? Where does it start to be shaded? At 6. Is it touching 6?
Yeah.
All right, so I use a bracket that tells the reader that I touch 6. And then where am I going? I'm going to infinity, and it's positive infinity, and I have parentheses. You never touch infinity. It's always a parentheses if there's infinity. Tater, do you understand that? Caden, do you understand that? Okay. Now, the reason I didn't want you to subtract from both sides. The reason that I didn't want you to subtract on the right side because I didn't want you to have a negative number. And here's why. You notice that we did addition and subtraction. We really didn't do multiplication and division. Did you notice that? And here's why. If you multiply or divide, we had this last year. Do you remember any of this? Is it coming back?
Yeah, 'cause you have to
All right.
flip it.
If you multiply or divide by a negative number, you must. It's not a choice. You must switch the inequality sign. All right. Now I'm going to go back, and the reason is logically it makes sense. It's the only difference between solving an inequality and solving an equation. And I went through it last year in 7th grade, so I'm not going to show you again why that works. But I'm going to take this same problem, and I'm going to do exactly what Ashley wanted to do in the first place. And I'm going to subtract 3x, or I'm going to subtract 4x from both sides. Okay? And so I get a negative x, because this is plus a negative, plus 6 is less than, what do I get over here? You get 0. Okay? And now I'm going to subtract 6 from both sides, and you think, well, you subtracted 6, do you switch the signs? No, you don't. It's only when you multiply or divide by a negative that you switch the inequality sign. So now I have a negative x is less than or equal to, plus a negative is 0 plus a negative 6 is a negative 6. And I'm going to divide both sides by what? Negative 1. So I take a negative x and I divide by a negative 1, and I have to rewrite it because now I'm going to switch the sign. Okay? Because I'm dividing by a negative. It has nothing to do with the negative on the 6. It has nothing to do with the negative on the 6. It has everything to do with I'm dividing by a negative 1. So notice I switch the sign. I get x, 4x, x is greater than or equal to 6. It's the same thing that I got here, isn't it? But I had to switch the sign. Ryan, do you understand that?
Yeah.
Okay. All right. So let's take a look at a couple of examples that will help us a little bit more. Because we're going to have 2 sections of this. One section is going to be pretty much addition and subtraction. The other is going to be multiplication. All right. So I'm going to do this one. I'm on number 5. I'm going to do a negative 5 is greater than, and by the way, the book uses a lot of different variables. I would be okay if you just used x.
Which page is this?
This is the next section, but I'll give you the examples. Okay? All right. Okay. What operation is being applied to the variable? It's division, right? What operation do I use to undo it? What do I divide, what do I multiply both sides by? Okay, I would multiply by a negative 3 because this is negative. Now, it doesn't matter if this negative is with the x, it's in the middle, or down here. I would multiply by a negative 3 on both sides. So when I do that, I take a negative 5 times a negative 3 is greater than, nope, I switch the sign, is less than a negative x over 3 times a negative 3 over 1. And notice I keep fractions, right? This cancels, correct? And a negative times a negative is a positive, correct? And a negative 5 times negative 3 is a positive 15. Any questions? All right. Now, I want to write it in set builder notation, but notice it's on the wrong side, right? So I do 4x, x is greater than 15. And it looks like I switched it, but logically these two mean the same thing. Logically, these two mean the same thing because it's opening up to the x on both of them. So then I graph it. And I put an open or closed circle on 15. Open. And I shade which direction? Which way? It's right. And I make sure you shade the arrow. Okay, so Allie, tell me interval notation. How do I write this? Very good, Allie. Excellent. Okay. Any questions so far? Kirsa? Caden? All right. So now, let's say I have a negative 3/5 x. Nope. Let's make it positive. Is greater than or equal to 3. And let's make it a negative 3. Okay, let's make it a negative 3. All right. I don't know if you remember how to do this, but we would divide by 3/5, but we don't want to divide by a fraction. We want to multiply by the reciprocal. So what am I going to multiply both sides by? 5/3. Okay. Now, do I switch the sign? This sign. Do I switch it? Jackson, yes or no?
Yes.
The answer is no, Jackson, because I am multiplying by a positive 5/3. It doesn't matter what I'm multiplying by, this negative 3, it doesn't matter what I'm multiplying to, it matters what I multiply by. Whew, that was hard to say. So, I am multiplying to this negative 3 over 1, Jackson. That doesn't matter. It's this number that I'm multiplying both sides by. If it's positive, I do not switch the sign. If it's negative, then I switch the sign. Does that make sense, Jackson? Okay, so this all cancels over here. That's why I did that. So I get x is greater than or equal to. Notice I put this as a fraction because this was a fraction. The 3's cancel and I get what? -5. Thank you. And so in set builder notation, I do squiggly x, 4x, x is greater than or equal to a -5. Okay? Now I'm going to graph it, and I want to show you this on the graph. A -5 goes in the middle. What number goes here on the right? -4. What goes here? All right, do I have a closed or open circle? Chuck? Closed, and it goes right on -5. Which way do I shade? Right or left, Caden? Right, I shade this way. And I shade it like that. Alright, so interval notation, Jackson, what do I got?
Bracket,
Okay,
-5.
stop. Braxton, finish it.
Very.
There you go. Alright. So I want you to turn to page, and it's very important that you turn to page 292. Page 292. We're going to look at numbers 12 through 38 even. However, you know, we have to do all three on this. I only want 12 through 28. We do the set builder, interval, graph. Any story problem that you have to do, you do not have to do all three. You just have to give the answer in set builder form. Did everybody hear that? So look on page 292. You're going to go to 38, but 30, 32, 34, and 38 are all just solving in set builder notation, okay? And then we're going to jump to page 299. This is a long assignment, Caden. 10 through 34, would you please turn to page, and we're doing evens, would you please turn to page 299. Now, number 10, do you have to do all three? No, because it's a story problem. You start doing all three at 12. How about number 30 and 32, 34? Do you have to do a story problem? Or do you have to do all three? No. Okay, so let's do one of these. Let's do number 30 on page 299. Thank you, Ashley. Let's do number 30. Read it with me. To remain on the cheerleading squad, Lakita must attend at least 3/5 of the study table sessions offered. She attends 15. If Lakita met the requirements, what is the maximum number of study table sessions? Okay, how do I do this? She must attend 3/5 of the study sessions. So X equals the study sessions that she has to attend. And how many does she have to attend? 3/5. So 3/5 X is what she has to attend. You understand that if I multiply the two? Okay? So 15. You know what? I'm gonna nix that. I think we're just gonna go to 28 on that section. Let's just go to 28. Can you change that? And we'll do our story problems on the other one. Okay? You want to see one of those story problems? Let's wait till tomorrow before I show you the story problem, okay? We have about 10 minutes. Oh, it won't be tomorrow. It will be, I just looked at the time. You only have 10 minutes. I want you to start on this. So tomorrow is win time. You have tomorrow and Wednesday to do this. It's due Thursday, okay? All right, and we'll do, if you want me to, I'll do a story problem tomorrow, or we can wait till Wednesday. You might want to do it tomorrow so you can get them in, okay?